Mr. Lore,
Yes.
I've noticed that on all the Google Classroom assignments, they
Mm-hmm.
all say at the top 100 points, even like some of them that don't even have things to turn in. So like,
It
is that some sort of automatic thing?
That's just the default. It's all credit, no credit. It's all the same. So,
Okay.
that's the default, and it's the first time I've used Google Classroom, so I just kind of let it sit. So the announcement from the district regarding attendance and grading and everything else came out on Thursday, which means unless you dropped in on my 5th hour class, which I'm guessing most of you have not, or did not because it's 5th hour, that means we have not had a chance to discuss everything in terms of attendance and grading. I was forwarded from Mr. Cusimano the email that was supposed to, I imagine, go out to all of the families regarding attendance and grading for secondary, for high school. And right there, it kind of gives you an idea. Basically, each week you need to check in with me, and the check-in is going to be any of our electronic submissions, whether it's a Google form or whether it's the Google Doc that we had this week. That's your official check-in, which means that it doesn't matter if you do it right or wrong. Make sure your name and your hours on there so I can see that you are thinking physics, even if it was only for 10 seconds to log in and get your attendance, whatever. Now, that will not count for a passing grade, but that will count for attendance. Do that each week. Grading, you can go back and modify and resubmit and do all those things anytime before our school year is over. So for example, if you went on this week, you went on the Google Doc, you typed in a couple sentences just to get started, and you stopped right there, you're clearly not done, but I see that you were in there during the week. I can give you credit for that. Then next week, 2 weeks, 3 weeks from now, you can jump back on there and you can correct it. I would suggest sooner rather than later while it's fresh, but whatever. Same thing for the Google Forms. Google Forms, you can submit as many times as you want. You don't overwrite what you already sent, which means that if you submit 4 times, there's going to be 4 different entries with your name on it, timestamp, so you can jump on there and do it once, either having some of it, none of it, all of it done, correct, incorrect, doesn't matter, name and hour, I see that you have attendance for that week, you're done. If you realize you didn't do a couple, if you realize you wanted to correct an answer, anything like that, you simply log back in, go to that Google form again next week, 2 weeks, 3 weeks from now, and you correct it. So what I'll do is, as we start getting close to the end of the year, I'll start going back to all those, and I'll see if any Google form submissions came in, because it's timestamped. So today is what, the 22nd of April. So I'll look through and see if anything came in after the 22nd of April. So if I'm looking through there and I see that week 3, which was, April 15th or whatever, if I see that there was a week 3 submission from you on May 1st, oh, okay, that's clearly something I haven't seen yet. I can go in, I can check your work and give you a thumbs up for that. So in terms of attendance and grading, they are different. I will be using the same single assignment for both. So just make sure you're aware. Getting it in on time is for attendance. Getting it correct by the end of the year is for your grade. None of my grades, UT assignments, Google Forms, Google Docs, none of mine have a deadline. The computer might say that I have to have a deadline, and I have one in there. If a deadline comes and you are locked out and you can't submit, let me know, like a UT assignment. If it's a Google form or a Google Doc, I'm pretty sure you don't get locked out. You can just keep on going, and I get a, if there's a due date on there, I get a little thing, hey, so-and-so has submitted late work. So that lets me know, oh, okay, I can go and check your work. So with that, my hope is that, again, you don't have to worry so much about the grades, because hopefully 60% is a fairly easily obtainable value. So hopefully you're not worried about getting it perfect, getting your 92.5% for your A or whatever else. Hopefully you're not stressed about that. So you can just kind of take the moment to just worry about understanding. That's what I'm hoping for. And again, deadlines, it can certainly backfire if you delay too long, and then next thing you know, you've got 5 assignments due the week before we're out of school. So that's on you to make sure you have good time management. But I'm not going to put deadlines out there, so that if you got something that's taking up time, or you say, "Oh man, he posted it late," well, there's no deadline, so you can rest easy there. So at the moment, where are we? We have finished up all things conceptual regarding electrostatics. This week was a practicum lab that I showed on a video that you were to explain using the Google Docs. Some people were answering questions, putting questions in underneath each number. So question number 1, and then people wrote their answer, and then question 2. I had some people just put a paragraph at the end. Doesn't matter to me. And I'm still getting used to using this Google Doc, Google Classroom thing. So I know that I can open up what you wrote and I can type, and it comes in as a different color. I don't know if it signals you, and if you know, you guys can unmute or use the chat and tell me, but I don't know if it signals you, hey, Mr. Lohr has modified your assignment. I don't know if you get an alert or not. So the first couple times I did it, I typed into someone's, and then I also sent them a message that says, hey, I put some corrections in there, some suggestions, and so you can go back in there and then you can make changes. So again, if you have any questions on how that works, I've never used it, but we can stumble through it together. I'm sure it's fairly easy to do. Otherwise, everybody wouldn't be using it, theoretically. Anyway, so we have all of our conceptual stuff done. We have now begun the math. So we have Coulomb's law equation from last week. We have a UT assignment that goes along with that. Electric field information coming out and voltage coming out very soon. And so again, as those come out, you can kind of continue working through your UT assignments. So if you don't know how to do a couple of the UTs yet, just hold off. And then I think that's where we're at right now. So we're kind of getting back into the math. So if that's your strong suit, we're heading that way very quickly. So I have a question on the chat that says, can I go over number 5 on the UT? How do you know if the forces are positive or negative when you add them to the final force? Okay, so I'm pretty sure that that particular question, and right now I'm opening it up so I can share the screen with you. I'm fairly certain that the question in question involves 3 charges. Come on, got a little bit of lag here. I believe it has 3 charges, and you are trying to figure out the force on each individual charge. Yes, that looks to be the case. So what I want to do is I want to do this right here. So what I'm going to do is I'm going to share with you not the UT page, at least not yet. What I'm going to do is I'm going to start right here. So in our notes, what we have here is Coulomb's law. Let's go back a slide. Coulomb's law has this equation right here. You'll notice 2 charges, not 1, not 3, only 2. This is the force between 2 charges. Newton's third law says they're going to feel the same amount of force. They will attract each other or repel each other, which means you're going to get charges, 1 left, 1 right, 1 up, 1 down, depending on how it's arranged. So what happens if you have 3 charges? Well, if you have 3 charges, I'm going to have some kind of a force between these 2. I'm going to have a different force between these 2. And then I'm going to have a third combination of forces between the red and the blue on the ends. A third charge does not affect the force between the 2 other charges. So these 2 charges, they're both positive. They are going to repel each other. This big blue positive 2 charge does not affect the force these 2 things have on each other. If we were to put it into an analogy, if I were pushing on you, the fact that gravity is pulling on both of us doesn't affect my push on you. Same kind of thing here. So what you're going to do is you're going to, reading the question here or the reading statement, find the force between each pair and do a force diagram. So what you're going to do is, advancing along, is you are going to look at each combination here. So these two, they repel with a red arrow. These two over here, they repel with blue arrows, which means the one in the middle has a blue arrow to the left from up here. It has a red arrow to the right from here. And now I can do pretty simple. We're not going to do, I don't intend on doing anything that's really crazy with two-dimensional questions. So mostly we're going to have just single one dimension, which means simple. Call this one positive because it's right. Call this one negative because it's left. And we've been doing vector addition since October, November-ish. So basically, positive, negative, just simply add them up with a negative sign between them. So you're actually taking the difference. Now, what I don't have here is what happens if I wanted to figure out the force acting on the red one. Okay, well, I've got this red arrow, and all I would have to do, and I don't have it on here, but let's see, I can, well, you know what? I think I can just add it in here. So let's add it in here. It's going to be a black arrow. These two are going to arrow and arrow. Those two are going to repel. So the arrow colors correspond to matching forces. So what do? I've got negative black arrow, negative red arrow, add up the two negatives. I get one big force going to the left. Down here, looks like I get some cancellation and a little force off to the left. So I have three pairs, going back a slide, I have three pairs. I have the left pair, I have the right pair, and I have the outside pairs, three pairs. I can do 3 Coulomb's laws, and I can have 2 arrows on every single individual charge. And at that point, it's old school November force addition in one dimension. So on the PDF of notes that I sent, I've got this page for you here, and all the writing that goes along with it is what I've just kind of discussed. And let's see here, I think this is, okay, so if you had 2 dimensions, the most I would ask you for 2 dimensions is if I gave you 2 that were perpendicular. So once I find the red arrow and the blue arrow, I can do Pythagorean theorem rather easily. So that's kind of the rundown. So if we were to take a look at the question that was asked, question number 5, you are given 1, 2, 3 different charges. You are told where they fall on a number line on the x-axis. So 0, 2.7, and 5. So your standard to the right as positive number line. Question 5, what is the force exerted on Q1 by the others? So looks like this is Q1, Q2, and Q3. So Q2, the 1.6 in my picture, and Q3, negative 2.6, they are both going to exert a force on this one. You have to figure out the direction of each of those. So figure out attraction, repulsion, see where they sit, and draw yourself some arrows. If I scroll up to question number 6, find the force on the second one, find the force on the third one. Now, don't just memorize that mine goes negative, positive, negative, because we all know that you might be given different signs for each of those, but do be aware that it literally says to the right is positive, so it looks like my answer is going to be to the left. Number 6 for me is going to be to the right. Number 7 is going to be to the left. So that's how you would go through and do a question like number 5. Does that help answer? Let me see if I actually answered your question. How do you know what the forces are positive or negative when you have to add them? So yeah, so draw the arrows. So literally draw them out, or obviously draw them in your head. Look at the arrows. Are they doing this, or are they doing this, or this? So are they together in the positive, together in the negative, or are you got one of each? And when you literally draw the arrows on your picture, you got your picture, your 3 spots on the number line, your 3 charges. When you actually draw the arrows on there, I think it kind of jumps right out. You can really see which one's positive, which one's negative. So UT question number 5 and 6 and 7. I think pretty much all the other ones simply say what is the magnitude of force, so you don't have to worry about a direction. But that one, it explicitly says to the right is positive.
I just had a quick question for the file this week for the straw practicum.
Yep.
what exactly should we write? Because there's not necessarily questions. I just am a little confused on
So
what to actually write.
you're explaining. So my numbers are telling you what's happening, right? What stage is happening. So the rubbing of the styrofoam in the fur, and then placing a pie tin on top of the styrofoam. So I'm telling you what's happening. You're telling me what is the electric result when that happens.
Oh, okay, so just talk like the attraction, how what goes on in the video essentially.
Yes, so you're telling
Okay.
me what's happening. So I say, step one, this is what you see. Why? Number two, this is
Oh,
what
okay.
you see and why. And so some people elected to do one big paragraph at the end, or you can put the paragraph at the beginning so it's easy for me to see, or others were answering it one at a time. Step one, this is what happened. Step two, that's how I would do it, but some people might look at like the big picture and just do one big paragraph. So it's up to you.
Okay, yeah. Thank you. That was the only thing I was wondering what to
Okay.
write then.
Okay.
Thank you very much.
Yep. It's 10:32. I'll mention a couple things here and then turn it over to you for questions. So remember last week we talked about the new attendance requirement for RCS. So basically each week you just have to show that you're doing something. And the easiest way is to simply jump online, go to Google Classroom, go to the lessons of the week, and do one of the electronically submitted time-stamped activities. So you have the Google Forms. You get one of those, at least one of those per week. That's the easiest because you can log in, name, hour. You can send just that. That says, okay, you're checked in. You haven't finished, but you've checked in. That works. Just this week, I put out one that you're going to answer in Google Forms and submit to Google Classroom. That's timestamped, so you can do that one as well. Again, you can start it and not finish it. That counts as your attendance for this week. UT assignments are obviously submitted electronically, but to find the timestamp to see that you were working and all that kind of stuff, it's really, really inefficient. So, so just do one of those two. And remember, attendance and grades are separate. So as long as you've checked in and showed that you put your name on the paper, you get credit. You were present this week. And you don't have to be present every week. It's just like if you're at school, you're sick, you can't do something for a week. You don't need to be fearful of missing a week of attendance. But there is credit, no credit being assigned. So when I go back and I actually look at and grade your assignments, I have to see if it's 60% or greater. There's that's the code that I'm using that I'm told to use for grading is it credit, is it no credit, or is it turned in but not quite up to par? So basically, did you turn it in and it's good? Did you not turn in anything? Or did you turn it in and it's still so-so and needs some revisions? Those are the three things. I don't care about the timeline for those, which means you can log in today to one of the electronic things, show some work. All right, looks like I've done something, and you can step away and just make sure before the end of the year you get back to it and submit good answers, whether it's Google Forms or the Google Classroom deal. Either one of those will work. And as you know, I gradually post solutions to most of these things. So you can always wait and kind of watch the explanation and then go back, whatever. So those are the key things that you need to be aware of for grading and whatnot. When it comes to the topics that we've been looking at, a few, obviously more physics related, is this new, for us, equation called Coulomb's law. So this is the first and so far only equation. More will pop up this week, but this right here is the first and only equation that we have so far. K is a constant. Q1 and Q2 is the charge measured in coulombs, which is explained 2 slides previous. A Coulomb is very, very large. So at the bottom, a reminder about prefixes, microcoulombs and nanocoulombs. The distances between the particles could be pretty small. Just make sure you're measuring in meters. And some things of note for you. Here's the constant you would use. This is called the elementary charge, the charge of a single proton or a single electron. We can't, at least we haven't yet, found anything smaller than that in terms of a charge. We can take protons, electrons, and break them into smaller things. As soon as you do that, no more charge. Or at least no, you don't get any charge that's smaller than that. If you need mass, why would you need mass? Because mass is going to determine what the force does. If I apply a shove to you, you go flying. If I apply a shove to the car doesn't budge because of a difference in mass. So that's why the mass of your particles are listed. So as it pertains to all the things that I wanted to bring up before turning it over to you for questions, I think that is everything. So the attendance and the grading ideas, so you're clear on those. And the grading, how it compares to the attendance, they are different. Even though I'm using the same item to do both, they are different. So make sure that you eventually get those turned in properly. If you have any old UTs you want me to open up, let me know. And otherwise, I think that's it. And then the new concept of Coulomb's law of the equation. So this week you have a practicum demonstration done on video, so you can kind of see that and then kind of do your best to kind of go through and explain. And may I suggest use the electrophorus lab as a guide to doing the straw practicum, the bouncing straw practicum. I've mentioned this before. When I'm doing my problems, I don't put any signs in. I just solve it, and then I end up getting my answer. And then I decide, is it an attraction? Is it a repulsion? If I've got two charges that are attracted, it means one's moving right and one's moving left. So just saying positive is right and negative is left doesn't quite work out anymore. However, having said that, if I switch over to this right here, having said that, and of course I can't see because the stuff across the top, let's see here. So if I look at this one right here, is this the one? Let's see here. You know what? I think I must have taken it out, which is a good thing because it was a bit of a challenge. So, so if you look here at the online, you should be good to go in terms of direction. The only time they ask for a direction, if I look at question number 5, question number 5 here gives you 0, 2, and 5 centimeter locations. They give you the charges, positives and negatives. When you come up here, I do believe they tell you to the right is positive. So you are using a standard number line there. So you are going to be putting in negatives and positives potentially. Don't just look at mine and say, okay, negative, positive, negative. I don't know how your numbers are going to match up. You know that they change for everybody, so just be careful with that. So they do give you a direction to use as a reference there. In the past, there have been questions where if two things attracted, positive times a negative gives you a negative answer. There have been times where you had to put a negative in if it was attraction and a positive if it was a repulsion. But I'm not seeing that here. So like question number 4, magnitude. So if it's a magnitude, that means no sign required. So good on past Mr. Lohr for taking care of that so that it wasn't, so that you didn't have to put in signs for attraction repulsion. So that's good. Tell me how to get it all set up. So I think what you should have is a file for yourself. You log in, you can type right in there. You know, Google Docs, they save automatically so I can see what you've written in. You can write in question 1, question 2, question 3. I had someone turn one in where they just put one big paragraph at the very bottom. Whatever. You can use any skills you have with Word or whatever else, and you can put in stuff into the pictures that I showed you there. My pictures are unfinished, so if you want to put in positives and negatives and arrows, I know some of you are good at that and some of you aren't because it's Word. Who draws on Word? So I get that. So whatever you want to do, take your time with it. Little bits, little bits here, little bits there. And remember, if you ever need a personalized Zoom session, you or whoever else, if it's you and some friends, or if you just want to have one, and I invite everybody at your approval. That's what Tuesdays and Thursdays are for, and I can also do those Monday, Wednesday, Friday after the 3 o'clock session is over. So just keep that in mind. So don't be afraid to ask to remind or whatever else. And like I said, I'll ask if it's, do you want it to be a private, just one-on-one meeting, or do you want it to be, hey, everybody, I'm meeting Thursday at 3, jump in if you want. You'll tell me what you want and what you need. If texting and emailing back and forth is not good enough.
So the is
Your voice was all digitized. It sounded like I was talking to a robot whose voice box was shattered or something. So all I heard was it was all pixelated. So you can, I don't know why. So you can always type something in. If you had a question, you always type it into the chat if the microphone doesn't improve. My Google Classroom page, there's the physical Olympic stuff. So if I come down here, so week 3.1 and 3.2, there was the video, obviously. So week 4.1 movie time. And so what I have is right there. So the electroscope and the electroforce demonstration, the explanation right there, as well as some other videos that I just simply looked online, found a couple videos that I thought were not too long, but did a really good job. And so there's to kind of help kind of clarify things as well. And then there's the practical, and I'll have 4.3 posted sometime during the day just to give us more information on this new equation that we have. That's the plan for today.